Hello everyone, I am Admile N.S, working as an assistant professor in SVERI College of Engineering, Pandharpur. So today we are going to study the analog and digital integrated circuits. So in analog and digital integrated circuits, we have to study the 7th unit, that is a flip-flop. So before start with the unit, we need to understand what is meant by a flip-flop. So in digital circuits, the flip-flop is a kind of bistable multivibrator. Means the flip-flop can store the state information. So it can store the binary digits, that is a bit 0 and bit 1. So in this unit we have to study the 4 types of flip-flop, that is a SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. So along with these four flip-flops we have to study the master slave JK flip-flop. So let's start with the first type of flip-flop, that is a SR flip-flop. So basically we have to study the 4 types of flip-flop. So in each flip-flop we have to study the logic diagram, truth table, characteristic equation and its excitation table. So the truth table, characteristic equation and excitation table are the important points regarding flip-flops. So let's start with the first type of flip-flop, that is a SR flip-flop. So here we can draw the circuit diagram for SR flip-flop. So it consists of 4 NAND gates. So we know the basics of NAND gate, that is a basics of truth table of NAND gate. So here we need to know the truth table of NAND gate. So for NAND gate, for the input 0 0, the output should be 0, and in other cases output should be 1. So how to draw the truth table for SR flip-flop? So after getting the circuit diagram for SR flip-flop, we have to go for the truth table of SR flip-flop. So in truth table of SR flip-flop, we have to write the type of flip-flop. So it is a SR flip-flop. So we have to write first column as S and second column as a R. Then we have to go for the present state and next state. So here in this circuit diagram we can mention Q1 as a present state and Q1 bar or Q1 plus 1 is the next state. So how to draw the truth table for SR flip-flop? So first we need to consider the binary digits. So for Q1 we can represent the standard binary digit, that is a 0 1 0 1 like this. Then for R 0 0 1 1 0 0 1 1. Then for S 4 times 0 4 times 1. So up to this is the basic concepts of the binary digits. Then depending on the Q1, that is a present state, we have to write the next state. Now how to write the next state? So to write the next state we have to consider the inputs of flip-flop. So the inputs of flip-flop is S and R. So here we can provide S to the one NAND gate, R to the other NAND gate, and always we have to provide clock pulse to the flip-flop. So in every flip-flop the clock pulse should be 1. So we can provide clock pulse as a 1. So in order to write the next state, we have to assume our present state, that is Q1, should be equal to 0. So here we can assume the present state Q1 is 0. So how to write the next state? So here we can provide S and R input to the flip-flop. So we have to consider each and every cases. So there are 8 cases. So in first case S is 0, R also 0. So the clock pulse always 0. So we know the output of NAND gate. So for 0 0 output should be 0. In other cases output should be 1. So the output of first NAND gate is 1. Output of second NAND gate also 1. So here we can write 1 and output of second NAND gate also 1. So next is first we have to consider the present state. So here we can consider present state as a 0. So depending on this present state we can write 0. So go with a circuit diagram. So 0 should be go to the next NAND gate, that is the 4th NAND gate here. So the input of this NAND gate is 0 and 1. So for 0 and 1, output of NAND gate is 1. So the 1 will be shifted to the upper NAND gate. So the 1 into 1, the output should be 0. So finally we assume the QN equal to 0, then next state also 0. So similarly, if we assume the Q1 as a 1, so go with similar method, then also we'll get Q1 is Q1 plus 1, that is the next state also 1. So here we can consider if S equal to 0, R equal to 0 and Q1 equal to 0, the next state also 0. If Q1 is 1, then next state also 1. So here we can write no change in the next state. Whatever the present state, the next state will be as it is. So similarly, for next state we can assume S equal to 0, R equal to 1, Q1 as 0, then Q1 as 1. Then in both cases we will get the next state as 0, 0. So if the 0, 0 is there, we can consider as a reset. Then for next third state, S equal to 1 and R equal to 0. Then again assume Q1 is 0 and Q1 is 1. So in both cases we can get output as a 1. So for 1 we can consider set. But for the last state, so in SR flip-flop, the input should be complement of each other. So if S is 0, then R should be 1. So if S is 1, R should be 0. So in last case, S1, R also 1. So it is the same. So the SR flip-flop cannot take this type of condition. So that's why the last condition we can call as a forbidden state. So similar truth table we can mention in a simple way. So the truth table, the input of flip-flops are S and R, that is 0, 1, 0, 1, 0, 0, 1, 1. So if 0, 0 is there, we can write no change in present state. We can write as a QN. If 0, 1 is there, we have a reset. So we write 0. If 1, 0 is there, we have a set condition. So we can write 1. And if 1, 1 is there, we have a forbidden state. So we can write a cross. So in this way, we can draw the truth table. So the next table is a characteristic equation. So we have to write the characteristic equation and find out with the help of K-map. So how to write the characteristic equation? So the characteristic equation we have to draw from the truth table of the SR flip-flop. So we have to consider the same truth table for the characteristic equation, but the representation is different. So how to represent the characteristic equation truth table? So in this type of truth table, we have to write first present state. So what is the present state? Qn is a present state. So we have to first write Qn. Then what is a flip-flop? So the type of flip-flop is SR. So we can write Sn and Rn. And at last we have to write the next state, that is Qn plus 1. So in this way we have to write the characteristic equation. So the Qn plus 1 is the next state. So again we have to consider the standard digit. So for Rn we can write 0, 1, 0, 1, 0, 1 like this. For Sn 0, 0, 1, 1, and for Qn 4 times 0, 4 times 1. So depending on this we have to write the next state. So that next state can be calculated from the truth table. Now how to calculate it? So we have to go for the type of flip-flop. That is a type of flip-flop is SR flip-flop. So in first row the S and R both are 0. So if S is 0, R is 0 and Qn is 0, what is the next state? We have to go for truth table. So if S is 0, R is 0 and Qn also 0, then the next state will be 0. So we can write here 0. So for next row, S is 0, R is 1 and Qn is 0. So again you have to go here. S is 0, R is 1 and Qn is 0. Then the output should be 0. So we can write here 0. Means we have to consider the first and we have to consider the type of flip-flop, that is S and R and the present state. So depending on this, we have to write the next state. So here we can write the characteristic equation. So after this, we have to implement this characteristic equation by using K-map. So how to implement it? So for implementation of characteristic equation, we have to consider the last column, that is a next state. So in last column we have a various term. So that term we have to write it from 0 to 7. So it having Qn, Sn and Rn, 3 input variables. So depending on the 3 input variables, we can define our next state, that is a Qn plus 1. So we have to write from 0 to 7 and we have to draw the standard structure of 3 variable K-map. So here we can draw the standard structure of 3 variable K-map. So after this, we have to put the cell numbers. So what are the cell numbers? We have to put the numbers and don't care condition, and we have to form the groups. So here in this K-map, we can form a one chord and one pair and write the appropriate equation by using K-map. So the equation is Sn plus Qn into Rn bar. So it is a characteristic equation. And at the last, we have to draw the excitation table. So now the excitation table is too important. Now how to write the excitation table? So again we have to consider the standard way to represent the excitation table. Now in order to represent the excitation table for this type of flip-flop and also next type of flip-flops, again we have to first consider present state, then next state, then type of flip-flop, that is a Qn plus 1, and type of flip-flop is S and R. Now how to draw the excitation table? So here the present state is Qn, next state is Qn plus 1. Again we have to write the present state and next state with the help of binary digit. So we can write here 0 1 0 1 and then in Qn 0 0 1 1. So based on this present state and next state, we have to write the Sn and Rn. Now how to write it? So in order to write this, again we have to go to the here Qn is 0, Qn plus 1 is also 0. Okay. So again consider our characteristic equation. So let's see here Qn is 0, Qn plus 1 is 0. So in order to draw the excitation table, we have to consider the characteristic equation table. So whatever the Qn and Qn plus 1. So the Qn and Qn plus 1 is 0 0. Then we have to write the Sn and Rn. So we have to write here Qn is 0 and last column Qn is 0. So Sn Rn are 0 0. Then Qn here 0. Qn also 0, but S is 0 and R is 1. So there is no change in S, but there is a change in R. So there is no change in S, that is a S is in both cases S is 0, so we have to write 0, and there is a change in R, so we can put a cross. So if there is change, then we have to put a cross. So similarly we can consider the 0 1 condition. So again for 0 1 we have to go for characteristic equation. We have to find out the S is 0. Sorry, we have to find out the Qn is 0 and Qn plus 1 is 1. So in third row we have a Qn is 0 and Qn plus 1 is 1. So at that time Sn is 0, Sn is 1 and Rn is 0. So we can write 1 0. So there is a no other combination of 0 1. So we can consider 0 1. Similarly we have to go for 1 0. Where is a Qn is 1. So in third last row Qn is 1, Qn plus 1 is 0. So in that case Sn is 0, Rn is 1. So we can write 0 1. So like this we can write the excitation table of the flip-flop. So similar method we have to follow for the next type of flip-flops. So in this way we have to consider the logic diagram, truth table, characteristic equation and excitation table. So the characteristic equation can be calculated from the truth table An excitation table can be drawn from the characteristic equation. Okay, thank you.